we are going to see how to find all the positive b values so that this series converges. Notice that for the exponent here, it's not n, but rather we have ln. So this is not like a geometric series where we have a number raised to a power. So let me do a quick review for you guys. If we just have the series as n goes from 1 to infinity of some common ratio r raised to the nth power, this is an infinite geometric series, and will converge if the absolute value of r is less than 1. But unfortunately, we cannot apply this to here because of the ln, right? The natural log function. So what can we do though? Well, because we actually have a natural log in the exponent, there's a log property that we can apply. It's not so common, but let me show you guys right here real quick. So the other thing, this is the first thing, the other thing is that suppose we have, let's say, some base for a raised to a power of log base b, and the input here is c. Assuming a, b, c, they are all good numbers, right? Positive numbers, not equal to 1, all that, because otherwise we can undefined or non-real results. So assume they are all good numbers. In this case, we can actually switch the a and c. So instead of base being a, we can have the base being c, and then we still have the same log base b, and then the a will be in the input of the log. It's a very neat formula. Why is this true? Well, let me just show you guys this real quick. So the idea is that for the a, we can actually write this as b raised to the power of log base b of a. It's true because this and that can cancel, all right, because they have the same base b. So we still get the a back. And then if you take this raised to the log base b of c, now this is an exponent, likewise that, we can multiply the exponents. So this is equal to, I will write it as b raised to, let me write this down first, log base b of c times log base b of a. Now we are going to do this kind of like backwards. I'm actually going to apply the exponent to this first and then to this later on. So you will see that this right here is just base b raised to the log base b of c, and then I'll raise that to the log base b of a. And then right here, by the same thing that we did right here, we can just cancel this and that, right? So we just end up with c for the base and then log base b of a, which is the same as that. So this is actually a key to this question. Now let's apply that and hope for the best. Here we have the series as n goes from 1 to infinity. The b will be the n, and then we have ln, and then the b will be inside of the natural log. So just like that. Now, this is a very different structure of the series because originally the base is fixed, and then we have this power, right? But now the power is fixed, and then the n runs through 1, 2, 3, 4 all the way to infinity, and then add them up. So in this format, we should actually be looking for the p series. So the third thing that we have to know is that if we have the series as n goes from 1 to infinity, if we have 1 over n to some power p, this right here converges if what? Pay attention to the p, that has to be greater than 1. Not equal to 1 though, because if p is exactly equal to 1, then we have the harmonic series and it diverges to infinity. I do have a video on that, over 1 million views, so you guys can go ahead and check that out. I show you guys a few ways to do it, so it's a very interesting result. But for this to converge, meaning end up with a finite value, p has to be bigger than 1. Okay, now let's put that into this form. I want to see the 1 over, so it matches better, right? And we can do so by looking at the series right here. Just bring that down to the denominator and make the exponent negative. So 1 over n, and then negative ln b power, just like that. So now you can see that n goes from 1, 2, 3 all the way to infinity. Yeah, this is just a number, n is just like the p here. So now the condition is that we have to look at this. This right here converges. I'm just going to write it down. Converges if this, which is negative ln b, has to be greater than 1. And now we can just solve this inequality. Divide both sides by negative 1, we get ln b. It has to be less than, because what? Divide both sides by negative, so just switch the sign and we have negative 1. Then we can just exponentiate both sides, meaning e to the power and e to the power. So we can get rid of e and ln. Now, e to the x is an increasing function, so we do not have to switch the inequality. So we will just get b is less than e to the negative 1, which is the same as 1 over e. So we want to find out all the b values that will make this series converges, right? Here's the original condition, and then the second condition is that b has to be less than 1 over e. So the answer is that b has to be in between of 0 and 1 over e. And this right here is the answer.